Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about the notes for writing abstract linear equations. And our objectives today are, first of all, to know from memory the slope-intercept form of an abstract linear equation and to be able to describe its parts. Objective 2 is write an abstract linear equation from a given graph. And objective 3 is write an abstract linear equation from two given points on a linear graph. And objective 4 is write an abstract linear equation from a given point in a given slope. So first we need to do a little review here. And the review is, what does linear mean? And linear means that there is a constant rate of change. So something is changing at a constant rate. And what that looks like on a graph then is linear graphs are straight lines. So let's move then to objective 1. So objective 1, we know from our work with applications of linear equations that we have this equation here where we know the dependent variable is always equal to the starting point plus or minus the rate of change times the independent variable. And the plus or minus here tells us that the equation is going to be increasing or decreasing with that constant rate. Now, abstract graphs, or in other words, abstract meaning graphs that don't really have any context to go along with them, they're just a graph with numbers and points. The linear abstract equation is going to be y equals b plus or minus mx. So here we can say that y is the dependent variable, that b is the starting point, and m is what we're going to call the rate of change, and x is our independent variable. Okay? So let's take a closer look. So y, the independent variable, y is the dependent variable, x is the independent variable. B is the starting point, but when we're talking about abstract graphs, we can say that that's also the y-intercept. So the y-intercept, in other words, is the place where the line crosses the y-axis. So that's going to be our starting point for abstract linear equations. And then m is the rate of change, but we can also call that slope with the abstract graphs. And important things to note here about slope. Slope's kind of a crazy thing. When slope is always going to be the change in the y direction over the change in the x direction. So I've heard people say the rise over the run. So that's a good way to remember it. It's the rise, or in other words, the y direction over the run, which is the x direction. And then whenever we're dealing with the slope, we want to make sure we always reduce that fraction to its simplest form. Okay? So let's go ahead and look then. That would take care of objective 1. And what we can also say real quick is that this equation, this y equals b plus or minus mx, is actually called a specific name. It has a special name. And that is called the slope-intercept form. So slope-intercept form is what's going to go down in the blank on your note sheet there. So y equals b plus or minus mx, that is the slope-intercept form of the abstract equation. Okay? So let's look at objective 2. Objective 2 says this: write the equation of the line given on the graph. So here we're given part A is, and part A, by the way, was on the separate graph paper that you have. We want to write the equation of this line. And we know that it's a linear equation because it's a straight line. It's increasing at a constant rate. So here we can start out by saying that we can always say in our graphs that the y-axis is the vertical axis. And we can always say in these abstract graphs that the x-axis is always the horizontal axis. And so then our dependent variable, the dependent variable is going to be y. So we're going to start our equation as y equals, and then we want to look for the starting point. And here the starting point is here on the y-axis. So it's a positive 2. And we can also call that b, or we can call that the y-intercept. So it's the point where the line crosses the y-axis. Now, this is an increasing graph, so we're going to say plus. And then the slope here, we can say, is going to be the rate of change. The slope can be the rate of change between either this dot to this dot here, or we can even go from this dot to this dot. And we notice that we're doing this first one here. we notice that we go up 2 and we go right 2. So let's try this. We go up 2 and we go right 2. So the change in the y direction was 2, and the change in the x direction was 2. So we can simplify that to a positive 1 slope. But if we look at the other two dots, we can go up 3 and right 3. So we would write that as 3 over 3, so the change in the y over the change in the x, and that's also reducing to 1. So those are actually equivalent slopes. So here we finish the equation by writing 2 plus 1 times x. And you can actually rewrite that equation in multiple ways. So if you've got y equals 2 plus 1x, you could write it as y equals 1x plus 2. You could write it as y equals x plus 2. You could even write it as y equals 2 plus x. Those are all legitimate ways to write that same equation. So then part B here, we know again that this is the y-axis, this is the x-axis. We're going to start our equation with y equals, that's our dependent variable, and then the starting point in this case is going to be a negative 2. So negative 2 is where the graph crosses the y-axis. And then our slope, we can count, is 4 in the y direction, so we're going to have 4 on the top, and then 3 in the x direction, so 3 on the bottom. So then we could say this is a decreasing graph because it's going downward from left to right. So we're going to say subtract 4 over 3 times our independent variable x. And we could rewrite that equation in many ways. You can either write this, or you could even write negative 4 over 3x minus 2. Those are both correct ways to write this equation. Let's look at part C. So here, the equation we're going to start with is y equals, and our starting point in this case is going to be, again, negative 2. And then this graph actually has a 0 slope, or it doesn't increase or decrease at all. It stays at constant nothing. So what we can really just say here is that we have a 0 slope times x. And if we want to rewrite this equation, maybe a different way, we could write 0x minus 2, or we could even write y equals negative 2. Because we don't necessarily need this 0x term, because any number times 0 is going to be 0. And lastly, we look at this example. We start with writing the equation y equals, and then our starting point here is going to be 0. And this is a decreasing graph from left to right, so it's going downward, so we're going to be subtracting. And then our slope from point to point here, let's get rid of that. So our slope from this point to this point, we're going to go down 4 units and right 1 unit. So that's a slope of 4 over 1, which then we can simplify to just 4. So we'd say minus 4 times x. And then you can also check that with this dot here. So you go down 4, right 1. So it's the same slope. And we can also write this equation as y equals negative 4x plus 0. Or we can even write y equals negative 4x. Because we don't need the 0 there. That 0 doesn't... it doesn't give us anything. So all 3 of these equations would work. Now let's look at objective 3. And objective 3 is this. Or the directions for objective 3 are this. Write the equation of the line passing through the given points. So here we're given 2 points. And we know that there's a line passing through the 2 points. So let's plot those two. So negative 4, 2. So negative 4, 2 is going to be here. That's the black dot. And then 1, negative 3, so 1, negative 3 is going to be here, the red dot. And again, we know that there is a line passing through those 2 points. And so we want to write the equation of that line. So we're going to start off again by y equals, and then our starting point here is going to be negative 2, so negative 2. And this is a decreasing graph downward, so we could say minus. And then our slope is going to be down 2, 4, 5. So 5 over 2, 4, 5. So 5 over 5, which then reduces to a slope of 1. So you have a negative 1 slope times x. Let's look at example 2, just like that. B. So part B, take negative 2, 1. So negative 2, 1 is the black point. The red point is 4, 4, so 2, 4, 2, 4. Going to be there. And then our line passing through the 2 points. And we can write the equation as y equals positive 2 plus, because this is an increasing graph, and our slope here is up 3, so we got a positive 3 over 2, 4, 6. So positive 3 over 6, which we can reduce to 1/2 x. So that would be the equation there. And then letter C, 0, 4. So the point 0, 4 would be there on the graph. Then the point 2, negative 2 is going to be here. So we create the line. And we can write our equation as y equals, the starting point here, the y-intercept, or b, the variable b, would be 4. And then our slope is going to be negative 2, 4, 6 over 2. So it's going to be 6 over 2. So the change in y over change in x. This is a decreasing graph, so we put a subtraction sign. And then the 6 over 2 reduces to 3. So we can just say y equals 4 minus 3x there. And now we move on to objective 4. So objective 4, the directions are this. Write the equation of the line with the given slope and passing through the given point. So here we know the slope and we know a point. So first of all, we need to plot the point. Negative 2, negative 4. So negative 2, negative 4 is right there. And what we're going to do is we're going to create the line when we're given the slope. So we know the slope is 2, so we can find other points on this line. So we could go up to right 1, up to right 1, up to right 1. Or we could go down to left 1. And that would create our line here that this passes through. And then when we're writing the equation of this line, we would say y equals 0 plus, because it's increasing, 2x. And let's look at example B. So here we have the starting point, negative 3, negative 2. So negative 3, negative 2. That's not the starting point. I'm sorry. It's just the point that it's passing through. And then we use the slope to find other points on the line. So we go use the negative 1/3 slope. So you go down 1, right 3. That lands there. Down 1, right 3. Or you could go up 1, left 3. That would also work. And here's the line that's passing through. So the equation of that line is going to be y equals negative 3 minus, because it's a decreasing graph, 1/3 x. And lastly, we have the point 3, 1. So the point 3, 1 is here. We're using the slope of 0. So since it's a 0 slope, we can just draw a straight line across here. It's a 0 slope. And now we need to write the equation. So y equals, it crosses the y-axis at positive 1 plus 0x, which you can actually just write as y equals 1. That would be correct as well. So this concludes our notes for abstract linear equations. And I will see you all on Monday.